So Adam's question about applying SUVAT to this was actually quite a nice question. And for those of you doing physics, you'll have seen the SUVAT formulas before. Okay. Now we can apply SUVAT to this, definitely. We just have to be quite careful about how we do it. Okay, so first thing we do when we're using SUVAT is we decide which variables we have or we're interested in and which variable we're not interested in, and then we use that to decide which formula to use. So first of all, thinking about the displacement, well, the diver starts 10 meters above the water. Yeah, when t equals 0, you've just got s of 0 equals 10. And then basically he's falling down. So when he hits the water, the displacement is negative 10. And the initial velocity we can get by differentiating our displacement formula, just like you've been doing anyway. So we take the initial velocity, so we differentiate first, so we get s prime of t is negative 9.8 t plus 4.9. Okay, so the first derivative of the displacement at 0, in other words, the velocity at 0, is negative 9.8 times 0 plus 4.9. So we're just left with 4.9. Okay, now, so we've got a negative final displacement. We've got a positive initial velocity. Final velocity, we don't know the final velocity. We don't know what speed he's going when he hits the water. And if we look at our velocity, all the formulas involving velocity also involve t, and we're actually trying to find t, so we can discount final velocity. Now the acceleration is given here as 9.8 meters per second squared, and that's the gravitational acceleration on Earth. Okay, and these numbers in this formula haven't come about by accident. If we found the second derivative of t, it's negative 9.8 t. Sorry, just negative 9.8. And that's what, and therefore these numbers working backwards to get the displacement formula, they've been chosen on purpose. They've not just randomly assigned it as negative 4.9. They've given it the value negative 4.9 t squared because they know that the gravitational acceleration is negative 9.8 meters per second. Okay, so we've also got this, and we've got negative 9.8 meters per second. Now here it's positive, here it's negative. Now this is important because basically if we plotted that graph, what's happening is the diver starting here at 10 meters, and then if we plot it against time, displacement against time, he travels up a little bit and then he starts to fall. And I think in this question here, you're actually finding the maximum height. And therefore, if you think about the initial velocity is positive, right? He's traveling away from the water, but the acceleration is negative 9.8 because he's traveling towards the water. All right. Now it'll work with these numbers if we use this as negative 9.8. So and then we've decided we can't use v, so that's out, that's out, that's out, and that's out, and what we're left with is this formula here, number 4. Okay, so I'm going to substitute everything I know into number 4 from this list here. So s is negative 10, and negative 10 is 4.9 times t, well t is what we're trying to find, plus a half times negative 9.8 times t squared. Now if we simplify that, negative 10 is 4.9 t minus 4.9 t squared, and if I then basically add the t to the other side, I've got negative 4.9 t squared plus 4.9 t plus 10 equals 0. And of course, I've basically gone back to the start. I've now just basically got the formula they gave me the first time around. And if you solve that formula, well, that's the only way now to proceed, is to solve the quadratic, and you'll get the correct answer. T is 2.01, I think it came to, and t cannot equal to negative 1.01. Just a final note, it wouldn't matter if you swapped all the positives and negatives around. Okay, so you could decide that you're going to consider the displacement to be how far away the diver is from the starting point. Okay, in which case this would be 0 and this would be 10. Okay, but we'd sort of have to swap the axis around. So this could be positive, this could just be 10, this could then be negative 4.9, and this could be positive 9.8. Okay, which if you were approaching this from a SUVAT sort of perspective, probably that is what you would do, so that you've got your positive acceleration value. But it doesn't matter, it's going to give you exactly the same final result.